Okay, looking at the given information that DC is equal to HS, we see these little outer portions. DC is equal to HS. And we're asked to prove that that line segment DH is congruent to that line segment CS. Well, I think we can agree that that's true because we've added CH to DC and we've added CH to HS. So it follows that those two line segments would be congruent. So how are we going to state that in our proof? Well, the first thing we need to do is write our given information that DC is equal to HS, and that is given. Then, knowing that I can add an equal value to both sides of an equation, so using my given equation here, I can add CH to both sides of that equation, but in order to do that, I first have to state that CH is congruent to CH by reflexive. Now that that's done, I can take that original equation, DC is equal to HS, and I can add CH to this side, and I can add CH to this side. And that was the addition property of equality that allows me to do that. Then at this point, now looking at what we have here, DC plus CH. Well, look at your diagram. DC plus CH is actually equal to DH. Why is it actually equal to DH? Well, that is the segment addition property, or segment addition postulate. So, DC plus CH is equal to DH. And that is segment addition postulate. And here we have HS plus CH, so let's use the segment addition postulate again and say that HS plus CH is equal to line segment CS, all under segment addition postulate. Have our notation. Then, looking at our proof now, I want to prove that DH is congruent to CS. Well, here I have DH in my proof and I have CS in my proof. And I can go to step number 3 and I can replace DC plus CH with my new value DH here. And I can replace HS plus CH with CS. What allows us to do that replacing? DH is equal to CS is our substitution property. We've just replaced those values. And you're done. Okay, with this proof we are given that segment BE is perpendicular to segment AC at point B, and angle 3 is equal to angle 4. Then we're asked to prove that segment BE bisects angle DBF. So BE, we want to prove that that bisects angle DBF. Well, what do we need to do first? So let's think about that. Where do we want to go with this proof? Let's make a plan. So I'm going to make a little thinking cloud. I know this might be corny, but that's okay. We want to try to prove that angle 1 is congruent to angle 2. Because if I can show that angle 1, this angle, is congruent to this angle, then by definition, that would prove that BE bisects that angle. So that kind of gives us a direction. Once I can show that angle 1 is equal to angle 2, we'll know that we're almost there. So let's write our given information so we can get started. So BE is perpendicular to AC, and angle 3 is equal to angle 4. That's given. Now, what do we know about perpendicular lines? Well, we learned that definition of perpendicular lines, that perpendicular lines form right angles. So where are our right angles with those two given perpendicular lines? So angle ABE is equal to 90 degrees, and angle EBC is equal to 90 degrees. Now the reason for that is because we know that perpendicular lines form 90-degree angles. From there, since both of these angles are equal to 90 degrees, what can we say about angle ABE and EBC? Well, we can now say that those two angles are equal. So angle ABE is equal to angle EBC. And the reason for that is because since they're both equal to 90 degrees, we can replace the 90 degrees with angle EBC. And so that replacing is substitution. Then where do we want to go next? Well, looking at our diagram, what do we know about angle ABE? Well, we know that angle ABE is equal to angle 1 plus angle 3. How do we know that? We know that from the angle addition postulate. And angle EBC is congruent to angle 2 plus angle 4. The same reason, the angle addition postulate. So then, from step 3 and step 4, what conclusion can we make from there? Well, since I have angle ABE is equal to angle EBC, I can replace angle ABE with angle 1 plus 3, and I can replace angle EBC with angle 2 plus angle 4. Now, what allows me to do that we know is a substitution property. So, angle 1 plus angle 3 is equal to angle 2 plus angle 4. And that is substitution. Now, thinking about where we're trying to go again, let's go back to our thinking cloud. We want to prove that angle 1 is congruent to angle 2. At this point, is it possible to prove that angle 1 is congruent to angle 2? I have angle 3 on the left and I have angle 4 on the right. If I could just get rid of those. Well, up in statement 1, I have stated that angle 3 is equal to angle 4. That was given information. So am I allowed to subtract an equal value from both sides of the equation? Absolutely. Angle 1 is equal to angle 2 because of the subtraction property of equality that allows me to subtract an equal value from both sides of the equation. So now that I have shown that angle 1 is congruent to angle 2, I can say that BE bisects angle DBF. And our reason is the definition of angle bisector. And we're done.